All right, today we're going to do 1-7, simplified expressions. And your target is I can use the commutative, associative, and distributive properties. So what is the commutative property? Well, the commutative property is actually kind of a silly word to say. It's not commutative, it's commutative. It says you can add numbers in any order. The key word for commutative is order. And it only works for adding and multiplying. So you can add or multiply. So think commutative, order can change with multiplication or addition. Think about it's like an addition sign twisted around. So for instance, if you have 3 plus 7, well, that's 10, right? Well, what if I change the order? 7 plus 3, well, that's also 10. So do you see why it works? Let's try 3 times 7. 3 times 7 is 21. Let's switch the order. 7 times 3, oh, that's also 21. They equal each other. So in general, we know A plus B, change the order, equals B plus A. Or A times B equals B times A. The associative property, when adding or multiplying again, means that you can group any of the numbers together. So when you think associative, think grouping. And again, it's only with multiplication or addition. Think, who do you associate yourself with? Who is your group of friends? So for instance, if you had 2 plus 3 plus 4, let's group together the first two and do our parentheses. 5 plus 4 is 9. But that wouldn't change if I would have done 2 plus 3 plus 4 and would have grouped together the 3 and the 4. Then you'd have 2 plus 7, which is 9. So in general, if you have A plus B plus C, it could equal, in parentheses, A plus B plus C, or A plus, group together your B plus C. The same thing works with A times B times C. You could have, in parentheses, A times B outside the parentheses C, or A outside the parentheses times B times C. And you get the same answer. The distributive property, which is by far my favorite of the properties, says you can multiply a number by a sum or multiply by each number in the sum and then add. So for instance, if you have 3 times 4 plus 8, you can multiply the 3 times 4 to get 12 and then add, because that's a plus sign, 3 times 8, which is 24. And you would get 12 plus 24 is 36. I call this I have a little trick for the distributive property. I call it the Santa hat. Because it looks like a Santa hat. If I have 2 times x plus 3, and I do 2 times x, and I get 2x, 2 times a positive 3 is a positive 6. Look it, do you see the Santa hat? Here it is. Here's the hat. Let's color this in red. And then you have Santa. It's the Santa hat trick is what I call it when you show your arrows, but you absolutely want to show your arrows. So in general, if you have A times B plus C, it's just A times B. And then always look at the sign. Look at sign for your operation. Because it's positive, you have plus AC. And your arrow means to multiply. So let's do some simplification. The next direction says, simplify each expression and state which property made your life easier. That's the whole point we have these. Well, let's see here. For number 1, 5 1/3 plus 4 plus 1 2/3. I don't know about you, but I think it'd be easier to go 5 1/3 plus 1 2/3, then add the 4. That made my life easier. What did I do? I changed the order. So I used the commutative property. So now I can add left to right. 5 1/3 plus 1 2/3. 5 plus 1 is 6. 1/3 plus 2/3 is 1. 6 and 1 is 7. Plus 4 gives me 11. Number 2, I think it would be easier. Instead of multiplying left to right, let's put some parentheses or group together the 7 and the 8. Oh, group! That means associative property. So I grouped them. 7 times 8 is 56. 1/2 times 56 is 28. That made my life a little bit easier. Now for number 3, 8 times 33 is pretty tough. But I bet you I could make 33. What are easier numbers to multiply? Well, I think it's easier to multiply 30 plus 3. Well, because isn't 30 plus 3 equal to 33? Absolutely it is. So let's do 8 times 30 is 240. 8 times positive 3 is plus 24. 240 plus 24 is going to be 264. And we use the distributive property. Let's do it again here. 7 times x is 7x. 7 times positive 2 is plus 14. And again, we use the distributive property. Now we're going to talk about terms. What are terms in an algebraic expression? Well, terms of an algebraic expression, they're just parts of an expression separated by addition or subtraction. So in this one right here, how many terms are there? Well, here's an addition sign and here's a subtraction sign. So it's parts that are separated. So you have 1, 2, 3 terms. They are, and you always look at your sign to the left. So you have 4x, a negative, it's a positive, sorry, positive 5y, and it's a negative 3. Like terms are simply terms that contain two things. One, the same variable, and 2, the same power or exponent. So some examples of like terms would be maybe 4x and 5x. But 4x squared and 5x squared also are. You could also have 3n squared n and negative 7n squared n because they have the same variables and the same exponents. Examples of non-like terms, 4x and 5x squared. They're not like terms. 3nn and negative 7n squared n, they're also not because their exponents aren't the same. A coefficient, we're going to talk a lot about a coefficient this year. A coefficient is just simply a number multiplied in front of a variable. I have in here a bubble. This is what you need to remember. If you are reading my mind right now, I would say always look at the sign to the left. Always, always, always. So for example, in negative 6x squared y, the coefficient's negative 6. In x, there's an invisible number there. It's actually a 1. Negative x is another invisible number, and I always write it like this. Negative 1 times x, so your coefficient is in fact negative 1. Let's do some examples. It says to simplify each expression by combining like terms. I always box or circle like terms, and I bet you can think about it, the sign to the left. So number 5, 3n squared n minus 2n plus 6n minus 3nn minus 6n squared. Well, I in fact only see 2 like terms. Negative 2n plus 6n is going to be positive 4n. Remember, the sign is the operation. I can't combine anything else. Nothing else has the same exponents. So let's just bring it down. 3m squared n plus 4n plus 3mn minus 6n squared. Now for number 6, before I can do anything, I need to distribute. If you can distribute, always do it first. So you have 14x plus 4 times 2 is 8 plus 4 times x is 4x. So when I look at my signs, if there's nothing out front, it's really positive. So positive 14x plus 4x is positive 18x, and 8 has nothing to add on, so it just gets brought down. Number 7, we've got a lot to distribute here. So here I'm going to go ahead and first distribute, and I get positive 5p. A positive 5 times a negative p squared is a positive 5p squared. And then let's bring down the rest. 4p plus 7p squared. I see a couple of like terms here. Positive 4p plus 5p is positive 9p. Positive 7p squared. Sorry, this should be a negative 5p squared. Minus 5p squared is positive 2p squared. And you can't combine these because the exponent is not the same.